This is a 2-storey secondary dwelling. It has garage and basement downstairs and an upper level with outside entertaining and a 2-bedroom, 2-bathroom and kitchen and living room on the upper floor.
We were contacted by the clients not long after the big bushfires in 2019, 2020. And it was really a call from them because they had been evacuated a couple of times over that period, and it had been fairly influential in how they were thinking about the property. It's a large property, access isn't great. There's a whole bunch of issues bushfire related that were really on their mind at that point in time. So the project actually started as really a resilience piece for the overall property in order to how to make it more resilient for bushfires, deal with some energy issues they were having because they're at the end of the power line, there's lack of power on the property, resilience from that point of view, ability to be able to survive, during these more extreme, more frequent events that we're experiencing at the moment.
The 2019 bushfires, I think, were a big influence on the design of this house. The clients had to evacuate numerous times. So this building's been built with keeping in mind that we could potentially bring livestock and equipment and put it in the lower section of this house where we've got smoke-proof doors and fireproof doors. And then from there, we move up to the passive house, which is above it, and we have claddings outside that are all rated for fire rating, and they're coated with fire rating products and the like.
The bunker on the lower level is concrete block core filled with a concrete slab over the top. It really is about bushfire protection. It's about keeping rain, moisture, fire, everything out. It's the big driver for that. Whereas the house on top is made timber frame, so quite traditional and simple in that sense. The cladding is timber. Now, so we're talking about timber and bushfire. In some ways that may feel contradictory. It's a charred timber, which is almost ironic for a place that may one day get hit by bushfire again. But it's an Australian hardwood, so in the bale rating of things, it's pretty high up the level of bushfire resistance in timber. So all of these things are sort of balanced together to make it more likely to survive. There are no guarantees with bushfire. Passive house part of the building was really a combination of the client's desire for something that works, comfortable, healthy, efficient. Efficient's interesting because it's partly around the volume of electricity required. There is a really poor power connection to what is a fairly large property, and therefore we can add to the grid. We can add to the demand for grid. So we had to make the building more efficient than we would do normally, and therefore all of these things come together. Our firm Envirotech has done a few passive house projects, and therefore we kind of had a good grounding in how to do it. That was lovely. The clients were just keen for a good quality outcome, and these things all morphed together pretty nicely. From the moment when we had a design and then finally sort of settled on the builder who we're going to use, who's Jared, the only real major change that occurred was around the building of the bunker on the lower level. We'd originally conceived it to be built from hempcrete, great material, lots of good sort of environmental carbon benefits. And through basically discussion, negotiation, and probably a better understanding of the location, that's how we ended up flipping to being a concrete block wall construction. And in some ways, it sort of feels a bit counterintuitive from an environmental point of view. But in reality, the site gets phenomenal amounts of rain. So the record is something ridiculous like 700 mils in a weekend. So we're talking a lot of rain. And therefore, because it's an unconditioned space, it's going to struggle to deal with the moisture in long periods of high humidity, whereas a house itself wouldn't, because it would dry due to the nature of the people in the house and heating and stuff like that. So that's probably the only significant change that occurred along the way.
Obviously swapping from hempcrete we wanted to use on the lower level, going to a Besser block to support the concrete slab above, and that solved a whole lot of challenges with the processes of the hempcrete. The lift well itself, we, after discussing with the architect, became apparent that it was going to be a problem to try and get any sort of lift coming up into a passive house and keep your air tightness. So it was designed to be built on the outside where the patio area is, still giving complete undercover for the occupants of the lift should they drive into the garages, then come up to a level which is undercover on the first floor, which is the same floor as the passive house itself is built. And there were other structures, other sort of considerations along the way with our thermal bridging. So we've got a concrete slab here that runs into a concrete slab on our patio, so we need to have a thermal break there to stop the transfer of hot and cold through into the slabs. We've got a steel beam that runs through the centre of the building up above us here. That extends outside the building, so we sort of, that metal ridge, if you like, has been designed with a thermal break, a plate between the steel, so it can continue out, but it stops the transfer of hot and cold into the building. So lots of little challenges like that, but that keeps it exciting. We all put our heads together and come up with solutions. The thing you have to concentrate on as a builder on these particular passive house projects is you are building to a standard, especially if you're going for certification, which is the only way I really want to go with it. We've got to meet that standard. So once again, the airtightness, the building to the plans and the specification to meet the passive house criteria.
The home's very airtight and well insulated, and we have external blinds that reduce the heat gain in summer, and all these measures enable us to stay cool. This becomes really important in heat waves or weather extremes, whether it's at the cold end or the hot end. And it's really about the building being able to weather storms longer by itself with minimal energy input. There were things in recent times in Texas where there was massive cold slaps in places which were not prepared for them. These buildings, because of their nature of being wrapped up snug and tight, weather those storms much better than others. And as our climate changes more and more, these things are going to be more and more important for more and more people. The Passive House certification really is saying that the building will use less than 15 kilowatt hours of energy per square metre per year for heating and for cooling. It's saying that it's airtight. It's saying that we have mitigated all the thermal bridges so that there is no risk of condensation forming inside the building, and that the ventilation system is going to provide fresh, filtered air for the health of the occupants inside.
And then with this particular house, we've got an extra HEPA filter that we can put in during bushfires and that sort of thing, which are a common occurrence in this area, that can really increase the air quality inside.
The house is airtight. It's passed a blower door test. So this is a test where one of the doors is opened and this large canvas door is put in its place. There's a big fan and it pressurizes the building. So this building meets the Passive House standard for airtightness, which is standards 0.6. The average Australian new home has airtightness of 15.4.
You're chasing 0.6 of an air exchange. We got ours to 0.25 of an air exchange per hour at 50 pascals. So we're very proud of that. It sort of is our guarantee as a builder. That's our check. That's our guarantee by an independent tester that this house meets the Passive House standard.
That's mainly due to Jared and Matt and their team doing a fantastic job of making it airtight. So the design didn't hinder them, but they've done a fantastic job.
Extra cost of building a passive house, you may be looking about sort of 15% from our experience. Having said that, the cost savings in the long run, they could be enormous given energy prices and where they're going these days, and a passive house is very efficient to run. But basically the main benefit of a passive house is your health. We have no mildew or mould or condensation inside these passive houses because of the way they're designed. So I think the benefits far outweigh the extra costs in the initial build. Down the road, you'll find this house is using very little energy, and you'll see that in your energy bills straight away.
Well, this house obviously isn't the cheapest house in the world. It's beautifully finished. It's had craftsmanship, attention to detail. It's absolutely beautiful. In reality, it's at the higher end of the cost curve. But the principles that underpin it, the reason the building works, the insulation, the airtightness, the ventilation, all of those things, they're completely attainable at all price points through construction. What we're really looking at when people look at the imagery that'll come with this video is the finishes, the surfaces, the cladding we chose, the kitchen, the curtains, everything. None of that is particularly relevant to it working as a passive house, providing health, comfort, efficiency for the occupants. They're almost different things. It just happens to be that this one looks like this and is pretty damn good.